Now we move on to our next talk, and that is by Martin George. It's on Grote Reber in Tasmania. Martin was previously in charge of the Launceston Planetarium, is now at a planetarium at Hive in Ulverstone. Over to you, Martin. You're muted.
Unmuted? Oh, thank you very much, Nick. I'll share my screen now, and I hope you can all see this straight away. There we go. Okay, is my screen sharing working okay for everybody? All good? Lovely, thank you. So Grote Reber is somebody who is considered to be the first radio astronomer, although when he was making his first observations in the 1930s in the United States, the term radio astronomy had not actually been coined. I'd like to start by giving you a bit of a background of Grote Reber. He was born in Wheaton, Illinois in 1911, and you can see here the earliest picture of Grote Reber as a baby sitting in that chair just there. But as Reber went into his teens, he got very interested in radio work, and he obtained his first radio license at the tender age of 16 with the very familiar, at least to radio operators, famous call sign of W9GFZ. And you can see there the address that he had in Wheaton, Illinois at the time. He graduated with a Bachelor of Science degree from the Armour Institute of Technology. His course of study was actually electrical engineering. Reber was not a mainstream astronomer. He was far more into radio engineering, but of course he's very famous for his work in astronomy. It was in the early 1930s that Karl Jansky accidentally discovered that there were radio waves coming from the Milky Way while he was using an antenna to find out the source of interference in radio signals. Reber took a great interest in this, and he built his first radio telescope in 1937 in a vacant lot next to his mother's house in Wheaton. And you can see here Reber as a young man standing on a platform near the receiver, and on the left the telescope itself, which was a transit instrument. It could not move in azimuth, it could only move in altitude. It frightened the local population, who had never seen anything like it before in their lives. Although it didn't frighten his mother, she actually hung the washing from it. Reber was well known for making the first radio map of the sky, and also for the fact that very few people accepted the idea of radio astronomy at the time, even though, as I've mentioned, it wasn't actually called that then. But he did manage to get publications in the Astrophysical Journal in 1940, and perhaps more famously in 1944, with his radio map of the sky that he put together using his transit instrument, taking measurements as the Earth rotated and at various different declinations as the points in the sky gradually moved across the field of view of his initial antenna. He, in the 1950s, he set up a sea interferometer atop Haleakala in Hawaii after maintaining an interest in radio astronomy for quite some years. Unfortunately, this device didn't produce any usable results. It collapsed in a period of very bad weather in 1957. But it was during that period, in the early 1950s, that Reber was becoming more and more interested in low-frequency radio astronomy. One of the problems about the very lowest frequencies, 10 megahertz and way down below that, is that the ionosphere prevents the signals getting through. And it becomes worse and worse the lower frequency you get to, so that by the time you get down to 5, 4, 3, 2 megahertz and so on, it becomes increasingly difficult. Reber made considerable studies of this and as to how he was going to make these observations, and realized that the best conditions for low-frequency radio astronomy, first of all, occur at night, when, of course, the sun is not above the horizon and the ionosphere is less charged. Also in winter, because the sun is lower in the sky. So once again, there is less ionization. And for a similar reason, during solar minimum, when the sun is less active. So there are three major things, but there was another one as well. He discovered that in specific regions of the Earth, the ionosphere was more transparent, less blocking, in other words, to the low-frequency radiation. And he did a lot of studies on this topic, gathering ionospheric data from many places all around the world. And this even included Macquarie Island, which is part of Tasmania, and he had been in touch with Graeme Ellis, who was then working for the Ionospheric Prediction Service, who provided him with some data from Hobart as well. But all around the world, he had this large amount of data, and came to the conclusion that the ionosphere was most transparent in two particular areas of the Earth, one being the Great Lakes area of North America, and the other being Tasmania. So he decided to move to Tasmania to make some observations. Here we can see a map of the various places that Reber worked. You can see Hobart there, just below the centre of this map of southeastern Tasmania. He began in Cambridge, moved up to Kempton, closer to the top, and Bothwell, right at the top of the map, just up there where he had his most significant installation. He came to Tasmania in 1954, and you can see here a picture taken in the following year by one of the stalwarts of the Astronomical Society of Tasmania, Colin Bisdee, who photographed Reber at Anglesey Barracks, which was the army base in Hobart. You can see him there next to a pillar for some transit of Venus observations that were made in 1874 by the United States Naval Observatory, complete with plants that were growing off the top of the pillar at the time. As I've mentioned, he had been in touch with Graeme Ellis, who you see here in this picture, and in 1955, they made use of some ionospheric prediction service equipment at Cambridge, which was very close to Hobart Airport. And in this blow-up of the picture you just saw, you can see the hut in the middle that was used for housing the receiving equipment, and some of the poles that were used to support the cage dipoles that they were using to make observations. They published a paper in 1956, and that paper was a landmark paper about cosmic radio frequency radiation near 1 megacycle, 1 megahertz in other words. They certainly were able to see the celestial sphere at down to about a bit over 1 megahertz. They made some observations which they claimed were from below 1 megahertz as well, but what happened was that they had definitely concluded that Tasmania was a great place for ionospheric transparency at very low radio frequencies, with those two at about 2 and 1 megahertz clearly successful observations. That was in 1955. Ellis went on to take a post in Queensland, and Reber decided to set up some dipoles at Kempton, just west of the town of Kempton, about 50 kilometres to the north of Hobart. You can see here on the left one of his anchors on the eastern side, which was a tree trunk that had been etched out so that the wire could actually be wrapped around the tree trunk. He had supporting wires at each side of a dipole, and the dipole was held above the middle of the valley. He initially started with 2 and then later moved on to 4. On the right, you can see a down lead coming down something like 100 metres from the dipole, which is not visible in that picture. But in the bottom right, you can see a shed that he had to store his receiving equipment together with a tractor. That shed later became a playhouse for the children of the people who owned that local property. The ground I found in the 2000s was full of artifacts from Reber's observations. Here we can see some of his footholds that he used to screw into tree trunks or trunks of sawn down trees in order to climb up to the tops of his poles. He did use some poles, not just stumps in the ground, depending on the lie of the land at the time. There were also a lot of wires and insulators that were found, having still been on the ground for over 50 years. This is a picture that was supplied to me by George Svensson, who visited Reber at Kempton in 1957. And in the background, you can see Reber's second shed that was placed on the ground between antennas 2 and 3. Reber was attempting to observe at 0.52 megahertz, which was far too low, really. He claimed initially that he had results showing a maximum in a particular area of sky, but later in 1982 wrote in a paper he wrote that he came to the conclusion that his results really weren't indicative of celestial emissions at all. Many of Reber's notes survive, and many of the images that I have here in this talk were kindly provided by the estate of Grote Reber and also the National Radio Astronomy Observatory in the United States. You can see here one of Reber's diagrams of a pole that was supporting a wire that attached to a dipole across the valley. He left behind many of these notes, typically on scraps of paper. He spent some time staying at the Rest Point Hotel, which later on was to become known as the Rest Point Casino, and made great use of the Rest Point Hotel note paper in order to scribble his diagrams. You can see at the bottom there, although it's upside down, a diagram showing a couple of inductors and a capacitor as part of one of the circuits he was using. So Reber certainly never wasted available resources. This is a picture of the fallen western end of antenna number 4. It fell in a storm in 2002. And as you can see to the right, just roughly in the middle of the picture, there are a couple of Reber's footholds there that he was using in order to climb that pole. Part of that pole is now on display at the Queen Victoria Museum in Launceston, adjacent to the planetarium where I used to work. I mentioned Macquarie Island, where Reber had obtained some ionospheric data earlier on. And you can see here the location of Macquarie Island in relation to Tasmania and New Zealand. Macquarie Island is actually part of Tasmania. In the late 1950s, Reber visited Macquarie Island with the aim of maybe setting up some dipoles across a valley down there as well. And here's a picture of Sawyer Creek that he took on his visit there in 1959. He put some stakes in the ground to mark the positions where he was intending to put the dipoles across the valley, but never actually completed that job. He wasn't terribly impressed with the conditions on Macquarie Island. He returned there from there in order to continue his work in Tasmania. And it was in the early 1960s that he began building his 2.08 megahertz array. This was near Bothwell in southern central Tasmania. 192 dipoles operating at just over 2 megahertz, as you can see here, and it covered an area of nearly 1 square kilometre. So it was actually Grote Reber who built the world's first square kilometre array between 1961 and 1963, making his observations between then and 1967. And here we can see a picture of the road that leads down or led down through the centre of the array. And on the left there, you can see the hut where he kept his receiving equipment. This is a picture of a counterweight. You see things like this with railways to keep wires taut. He had counterweights all over the place to make sure his wires were kept straight. He engineered his antenna array at Bothwell very, very well indeed. In fact, some people have commented that he over-engineered it to make sure that it would last for a long time. He spent a lot of his own time climbing the poles too, in order to attach the antenna wires to the tops of the poles and to carry out maintenance. He also had some special shoes made with spikes with sort of curved bits of wire so that he could attach himself to the pole without falling down, although he did on one occasion fall from one of the poles and sadly broke his arm. This was the result of his work at 2.085 megahertz using the Bothwell array. You can see there the contours of equal radio intensity. He tried in the middle of the 1970s in the next solar minimum to work at 1.155. Unfortunately, the results were very poor. In fact, he didn't really receive any results at all. He commented in his diaries about how badly he was going with that work, and at one stage mentioned that one of the highlights was listening to sports results from 2WG radio station in Wagga, which he could pick up at around that frequency. There were, of course, a lot of AM radio broadcasts around that area, and this was a big problem for Reber. So he never succeeded in obtaining results at that frequency there. Reber had a few problems when he was putting his array up. On one occasion, he received a sting from a platypus, which ended up with him in the Royal Hobart Hospital. They can be very, very painful, actually. And with his Bothwell array, one of the stipulations from the landowner where he set up his poles, from which he rented the space for his use, was that the animals would be allowed to graze around the poles. In other words, the farmer wanted to keep his paddock in operating condition. And you can see here a bunch of sheep with some of his poles supporting his antenna array in the background. But the animals were a bit of a problem. And at one stage, Reber wrote in his diary that cow number 343 is a pest. Apparently, the cow was rubbing up against some of his equipment and causing a bit of a nuisance. That was in 1975. Reber one day went to the array later on in 1975 to find out that the array was in a bit of a mess. Wires got entangled in machinery and come down. The whole place is a big muddy mess. Don't feel like even trying to put the wires back up. And of course, this was at the time when he was having trouble getting any results, whatever, at that frequency just over 1 megahertz. By the 1980s, the array was certainly not in use, and you can see here a picture supplied to me by Hilary Kane of Reber pointing out to her what was left of the array. And on the right, you can see the shed, the shed that had the receiving equipment in it. In Tasmania, Reber gave many talks, especially to the Astronomical Society of Tasmania. Reber was not a believer in the Big Bang. In fact, he gave many talks titled "The Big Bang is Bunk," and he was also interested in various other things as well. Energy-efficient house that he built, for which he received an award. He also made a lot of measurements of plants, plant heights, plant widths, and so on and so forth in his experiments, and became quite well known for his work on bean vines, where he twisted the bean vine in the opposite direction to the one in which it wanted to grow, because he was convinced that in doing that, he would get a better ratio of the weight of the beans to the weight of the shucks. And here you can see a page from one of his papers which purports to show that he had positive results in that area. He was also very interested in how long objects lasted, their lifetimes and so on. He made many light globe studies and kept the circular fluorescent tubes that he had all over his house, because he knew they were energy efficient, of course, marked where they were removed from and on what dates. We found a lot of this kind of stuff in Reber's house when we investigated it in early 2003, after Reber had passed away. But one of his pet loves was efficient transport, and he rode his bicycle with an engine on it called a bike bug around Bothwell, and kept records of the wind speed and the maximum speed that he could get to with his bicycle. He was also very interested in the energy efficiency of cars, and discovered that Renault cars seemed to offer the best value for money in terms of petrol consumption among all the brands of car. He concluded, rightly or wrongly, that the optimum speed of driving these cars was 40 kilometres an hour, which greatly annoyed the local residents of Bothwell, because they sometimes got stuck behind Grote on the twisting and turning road from the Melton Mowbray pub on a Friday night when they just been down for their counter meal, and Grote was on his way back to Bothwell. They got stuck behind him. He constructed in the United States his electric car called Pixie, using bicycle wheels and various other odds and ends, and gave the local children in Bothwell rides around the town. Pixie is very famous for that, and in fact it's on display in the Reber Museum, which you'll see a few pictures of in just a few moments. This is Reber's last birthday party. He had a very, very close friend who lived in Hobart, who hosted him for his birthday every year. He turned 90 in 2001 and sadly passed away in December of 2002, just 2 days short of his 91st birthday. So there we have Reber at his last birthday party when he was 90 years old. My colleague, Dr. David Jauncey, and I were asked by the executor of his estate to go through the contents of his house and catalogue them. there was a lot that we found there. Reber had kept a lot of radio equipment, all sorts of odds and ends in boxes with writing on the outside as to what was in the boxes and so on. We found a lot of his notes, often circuit diagrams written on the back of bank statements to save paper. His house was really a treasure trove of the history of what Grote had done in Tasmania. We had it all boxed up. Anything that wasn't boxed up, we boxed up, and that was transported to the Queen Victoria Museum, where I used to work, where we had an archivist do a complete catalogue of the contents of Grote's house before it was eventually moved to its final resting place, which we will see in just a moment. You'll see here a general picture of Grote's house with his water tanks, his cars and so on. And on the left, you can see a shed, which was in fact the receiving shed for the array. He had it moved there when the array was no longer in use. Reber never wasted a thing, so he had it brought there and put on foundations around 1984. We didn't realise that that was the case at first, and when we did, we organised with the people who had purchased Grote's house in order to get the shed taken away and moved into the Grote Reber Museum. And here we can see the shed on the back of a truck as it was moved from Bothwell to near Hobart in October 2004. It managed to make the journey with only a couple of minor incidents, including the loss of one give way sign that the shed collided with along the way. And here we can see the Reber Museum, which is near Hobart at Mount Pleasant, at the site of the university's Radio Astronomy Observatory, where they have their 26-metre reflector. It was opened in 2008. We had a model of Grote's original radio telescope from Wheaton, Illinois, built as part of the exhibits. And right up at the back, you will see a yellow wall. That is actually the wall of Grote's receiving shed. Inside there, we put on display Grote's Pixie, his car, and there's even a mannequin of Grote operating his radio equipment inside there as well. If you haven't been there before, I hope that someday you get a chance to visit the Grote Reber Museum. So there we are. In a nutshell, that's the story of Grote Reber, the world's first radio astronomer, and his life in Tasmania. I'm quite happy to take questions by email, and you can jot down my email address on this slide if you would like to do so. Thank you very much for having me this afternoon.
Thank you very much, Martin. I really learned quite a bit about Grote Reber. I did hear him once talk about his cosmology, but I'm afraid I couldn't make much sense of it. We have 2.5 minutes. There's a question from Tona. By working in Tasmania, was Reber fairly isolated? Where was his funding? Where was his funding from? Did University of Tasmania help him, or did the federal government help him?
No, basically, although he maintained an association with the University of Tasmania and for a time, of course, with Graeme Ellis, his funding was separate. He was funded by the Research Corporation in the United States over a very long period of time. He also had his own funds, but basically the Research Corporation were his source of funding. In the earlier years in the United States, he had a few jobs as well. So he was able to survive on that sort of income as well. But in terms of isolation, Nick, you were mentioning that, or Tona was, I'm sorry. He was very much a loner in many ways. Even though the University of Tasmania were also doing a lot of low-frequency radio astronomy, and that's a completely different story, although it's related to what Reber was doing. Reber went it alone, and certainly after his association with Ellis in 1955, his work at Kempton and at Bothwell really was by himself with local people that he hired to help him build things and so on. But it's also said that really his association with Graeme Ellis was also something that started off the long period of low-frequency radio astronomy in Tasmania, where the university built antenna arrays near Hobart Airport, at Richmond and at Penner. So Reber played a big role in that future.
All right, thanks, Martin. Ron, we have 30 seconds. Do you have a question?
Oh, I was going to make a comment. I'll do it in 30 seconds. There are so many Grote Reber stories, of course, that we can't possibly discuss them all. But on the Big Bang is bunk, when I invited Grote Reber to CSIRO Radio Physics to talk about his version of the history of radio astronomy, which was a fascinating topic, with a wry smile, he instead gave a talk on why the Big Bang is bunk, to the annoyance of all the staff that were present. He had some very unusual ideas. And the concept, since other people said I was wrong in the past and I wasn't, I'm probably not wrong this time either.
All right. Thank you very much, Ron. And thank you very much for your talk, Martin.